All right, well, welcome everyone. I am JJ. Let's tackle an example problem. So this one, we're saying we have a beam here. It's fixed at A. Let's find our support reactions. If we're looking for support reactions, we should know that means we have to come in and apply equilibrium equations to find those. Anytime we're applying equilibrium equations, we should have a free body diagram that goes in to model what we're actually working with. So let's jump in and draw our free body diagram first. We can show this entire beam as just one straight line here. I'll just take it directly right down below that original beam. At the right edge, let's just work across it from right to left, draw everything in. So there is an applied force here that goes down and to the right. That was 39 kips. 39 kips. Our angle on here, we're at a 5, 12, 13 triangle, despite what it looks like I drew. 5 vertical, 12 for our hypotenuse, and then 13 we can just leave as an implied part, or we can come in and label it. Either way is fine with me. 5, 12, 13. We also have right here a couple moment that's being applied on this. So let's take that on here as well. It's going counterclockwise up above, so we'll just show that there. 30 kip feet. If I go to the left from here, as I move over 12 feet, I get to a distributed load. So let's label 12 feet in here. 12 feet. I'm over the next 8 feet of this, I might have my distributed load acting. So I'll label that 8-foot distance right now. And then just sketch in my distributed load. It's a rectangle, so we'll just show it with a handful of lines coming down off the top. Our number of lines don't matter for us. Just enough to get this. Obviously, it's a distributed load. And our height for this is 3 kips per foot. So we can label that as well. 3 kips per foot. Finally, as I move to the left again, 5 feet, my last distance in here, I get to that fixed support. Fixed supports always resist force in the X. I'm going to guess I have an AX going to the left as a result of that. AX. Fixed supports also resist force in the Y direction. I'll guess I have an AY going straight up here. And the one thing that people tend to forget on this, fixed supports always resist moment. We have to have a moment variable in here. So I'm going to guess that this goes counterclockwise. And then I'll just put in an unknown MA as a variable in here. 3 unknowns that my fixed support resists. I can find all 3 of those just using statics for everything. So let's come in and tackle that. I'm going to start by summing forces in the X first. I'll get it up over here. If I sum up my forces in the X direction, I have the X component of this 39 kip force, and that would be the X leg of the triangle, 12 divided by the hypotenuse, 13, times the force, times 39. The only other force that points in the X direction is AX. It's pointing to the left, so we subtract it off. Minus AX equals 0. Again, when we make equilibrium equations, we should write the full equation out, even when it's one that is easy to solve out like this. Stay with good habits on everything. Once I know that, I can solve for AX. I'm going to get that AX is equal to 36 kips. I get a positive number out from my equilibrium equation. That tells us in my free body diagram, I guessed the right direction. So I can add in direction into my answer. It is to the left. From here, I can come in and say, well, I have one unknown in the Y, and I have one moment as an unknown as well. I could do forces or moments next. It really doesn't matter on this problem. Let's come in and sum up our forces in the Y direction. Summing our forces in the Y. I have AY going up, so I'll have to add that into my equation, AY. I have a distributed load coming down, and I have a force over here coming down. Let's get that distributed load in here. Remember, when we're dealing with distributed loads, the force is just the area of that distributed load. We have a rectangle, so area is just base times height. Our base is 8, our height is 3, so say minus area, 8 times 3. That's the force of that distributed load. And then minus the Y component of that 39 kip force, which would be minus our Y leg of the triangle, 5 divided by the hypotenuse, 13, times the force, times 39 is going to get us all the way out to 0. just moving my two negative terms to the other side. I get an AY equal statement. I'm actually going to end up in here with my AY is 39 kips. I get a positive number here when I solve my equation, which means I guessed the right direction for AY in my free body diagram. I can get that direction labeled in my answer, going up. And then the last unknown that I need is MA. So I'm going to come in and start out by just summing moments. We'll say positive, goes counterclockwise. I'm going to sum my moments up about, and I can choose a point in here. Since I know AY, I could pick any point on the beam. Actually, since I know AX and AY, I could literally pick any point anywhere in the world, and it would work out for us. But we could be smart and just say, let's sum moments up here at point A. No matter where I sum moments about, though, this variable MA is going to show up in here because it's already a moment. I don't have to multiply by distance on it. So I'm summing moments about A. And I'm going to say the first variable I'm going to put in here is my unknown I'm solving for, MA. And then I'll get my moment from everything else. This is already a moment. I don't need to say times distance in here. A couple moment times distance isn't anything useful for us. If you're doing that, I would mark you down pretty harshly for it. But let's come in then and get our moment from this distributed load. It would cause a clockwise rotation. So we'll subtract it out, minus, and we need moment is force times distance. So the force is just the area, base 8 times height 3, times the distance from A to the middle of that distributed load. And to the middle, because it's a rectangle. If it was a triangle, it would be a different formula. Really, to the centroid of it. Centroid of a rectangle is in the middle. But so from A, we have to go over 5 feet to get to the beginning of that distributed load. So 5, and then I keep going. So plus, and I need to get to the middle. So half of 8 plus 8 over 2. These first two, 8 times 3, that's the force. 5 plus 4, 9. That's going to get me my distance term in there. Both of those have to be there for moment, force times distance. If we come over to the right edge, I have a couple moment in here. I still don't multiply by distance on this. It's going counterclockwise, so I just add it in. Plus 30. I assume counterclockwise is positive. It's going counterclockwise, so we add. My x component of this 39 kip force would pass right through A, so I can eliminate it. It won't cause any moment at A. I just need to get the y component of this. That's going to cause a clockwise rotation, so minus force times distance. The force, just like it was when we summed forces, would be the y leg of the triangle, 5 divided by the hypotenuse, 13, times our force, 39, times our distance from A to that force. What's the perpendicular distance, that shortest possible distance from the line of action where my arm's at here, all the way back to A, will be 5 plus 8 plus 12, or 25. Times 25 gets us all the way to 0. Notice if I didn't put in that MA term in here, this is a nonsense equation. Negative 8 times 3 times 9 plus 30 minus this is not equal to 0. That MA has to be in here for me to actually have a valid equation for this. Don't forget your variable in here. Practically what's going to happen is you get the right magnitude for this to work out, but you'll get a sign error and which direction is it going. And we got to be able to get that right. But solving this for MA, I would get that my moment that fixed support A resists is equal to 561 kip feet. I get a positive number out from this equation, which means I guessed the right direction in my free body diagram, so I'll include the right direction in here. Always for support reactions, we're going to give it as a positive number. We did that all 3 times. And then say the correct direction on it. And we got that all 3 times in there as well. But hopefully this is a useful video for you. If it was, go ahead and hit the like and subscribe buttons. Stick around. Let's get you in A with JJ.